2.4 is taking us into another section where we're talking about variables on both sides. For the most part, this is really the last level of solving that you really need to know in terms of overall, but there are some things we're going to be doing probably tomorrow as we look at what we call literal equations and going on from there. But a real quick self-check for yourself. Just make sure you understand how to do one-step equations with work. Make sure you know how to do two-step equations with work. And make sure you have at least a decent grasp on distributing and combining like terms like we did in yesterday's multi-step problems. Today is actually, again, pretty much your last lesson. Everything else, again, just gives you a process to use at least to a fundamental solving problem. Just be sure to work hard today, and if you do that, you'll be in great shape for the chapter test. Again, if you're still having issues solving, then it's going to be a tough chapter for you because really the whole chapter is just on solving. So the essential question that we're looking at is, where does this fit in with everything you've already learned? Pretty much the material we learned just fits below our last lesson's rule, which is simplify first. Once both sides are simplified, you'll start to see that there are variables on both sides. In order to solve an equation with the variable must clearly declare one side. So, looking at the problem here, we've been taught to move everything away from x, so if we drew our line and said x is on the right, then I'll just move the 3 over here. But if I move the 3 over here, now the 7x doesn't want it, so you send it over there. And then of course the 2x doesn't want it, so you've got to send it back over. So again, knowing that the variable wants to be alone, you cannot get the variable alone if both sides have a variable, so you fix the issue by moving the smaller variable to the other side. The reason you want to move the smaller variable is because it keeps your variable positive. And in algebra, the toughest thing we have to deal with is our negatives. So again, move the variable using its opposite, but move the smaller variable to the other side. That way it stays positive. It doesn't mean that you'll mess up if you don't choose a smaller one. Sometimes you'll accidentally pick the wrong one, but there really is no wrong one as long as you follow the rules and do what you're supposed to do there. But looking at these examples, talking about 3x plus 17 equals 5x plus 9, again you have a 3x and a 5x. The easiest thing to move, or the smallest thing to move, is the 3x, so we'll subtract 3x by using its opposite. That is a positive 3x, so we'll use a negative by subtracting 3x from both sides. These go away. 17 comes down with 2x plus 9, and now we are what we would call home, where we would simply subtract 9 from both sides, getting 8 equals 2x, and then divide by 2 to get 4 equals x. Again, checking that, 12 plus 17 is 29, 20 plus 9 is 29. We know it worked. Second question. Again, we got 10x plus 21, 2x minus 3. Notice that the left side is simplified and the right side is simplified, so we're going to move the smaller x over to the other side, getting 8x plus 21 equals negative 3. Subtracting 21 from both sides, you get 8x equals negative 24, and then dividing by 8, you get x equals negative 3. Now, on the computer, I believe it's forcing you to move the smaller one, so if you go to do all the steps with the boxes on the computer and you do not move the smaller one, it's probably not going to work. But again, if you have an issue with that, just wait and talk to me about it tomorrow when I'm back in the room, and that way I can try to help you out. But other than that, if you try to move 5x, it's not going to work because it wants everything to be positive whenever you do that on the computer. Looking at the third example, you have 7 parentheses x minus 5 equals 6 parentheses x plus 5. Again, this is not simplified, that is not simplified, so the first thing we must do is distribute 6x plus 30. And from there, again, we want to move the smaller x, knowing that this is our middle, so subtract 6x from both sides. And then add 35 to both sides. Which gives us 65 as our answer. Again, combining stuff we did from yesterday to today, the only difference is that you have to make sure you understand that, again, variable on both sides, you've got to declare a side, otherwise it does not work. So once you've gotten the left side simplified and the right side simplified, move your smaller x and continue from there. So again, we've got to do 2a minus 12 here. We've got to do 4a, and then this negative gets distributed, so minus 2a and minus 12 is where you have to be careful. This is still not simplified because those two can be put together. So 2a minus 12 equals 2a minus 12. Notice how these two a's need to move, and they're both the same. So what happens is, because they're opposites, what comes down is negative 12 equals negative 12. And anytime all of your variables go away, there's two options. If your answer is true, it is all real numbers, which is what this is. If it was false, and you might want to write this down, it's just no solution. In other words, these a's are going to cancel out, so no matter what you do on this one, it's going to be true, which means that there's a whole bunch of solutions that will actually work. Whereas if this was false, no matter what you plug in, it's not going to work. So these are your two situations that happen whenever your variables actually go away. So just be careful with that. Now, your notes talk about inequalities, and we're really not going to get into inequalities, but I will go ahead and introduce you to them now. This is a chapter 3 concept. Again, we really won't get into this. I don't even think I'll do it. I think I'll probably just work these out real fast just to show you some things here. Again, with inequalities, the general rule is that the variable must be on the left side, the symbol flips when sides are changed, and the symbol flips when switching signs. So again, this just a quick introduction. You're not going to have to worry about this on your homework, but the solving is still the same. And so what will happen is you will add 14 to both sides. You will get negative 6, keep the sign the same, and x. But notice now that the variable is on the wrong side, and so what we have to do is bring our variable over, put our 6 over there, and also, because it's pointing at the 6, switch the sign. So I'll just do one more real fast just to kind of show, and then we'll call it a day. So here we would subtract 16 because, again, we want to get x by itself. We will get negative x, copy the sign, and get, I think, 13. The problem is that our x is positive, and this is where I'm trying to show you to make sure you switch your x, because when you switch your x, that changes and the 13 changes. Again, I'm not so much worried about these because this was something I put on last year's notes, and we are actually going to separate chapter 2 and chapter 3. You just need to make sure you learn this stuff because chapter 3 is also going to be in the first quarter, and so that means that we have to take a chapter 2 test pretty soon, probably next week, if not right after the end of next week. So now that you've seen every fundamental skill you're going to use at this point, again, focus on applying the necessary strategy. Simplify both sides first, declare a side for your variable, solve as usual. Again, in the end, solving is simple. It's just that you need multiple steps to get to the end sometimes, and your patience is going to be important. Other than that, again, go to your Math Excel, work on what you can. If that work from today gives you too much trouble, just move to the other stuff and get some review on all that. But again, remember, chapter 1 is free. Chapter 2 is what you're really focusing on, and just make sure you're getting as much of that done so your homework grade doesn't drop. Other than that, good luck.